thank you for coming. I'm Pere. Yeah, I will talk about everything about data engineering. Thanks also to the previous talk this morning from Xing, who already know a little bit what data engineering is. So yeah, that was a good thing. Before I forget, so one of the people I work for is Springernature. This is the editor of Nature, the magazine. I work with an awesome team in Berlin. If you ask questions, I mean, it can be whatever question you want to ask. I basically don't want to get them back home. It's very heavy, so they are here for you. I also got nice stickers from my team in Berlin, so I are here for you to take. Okay, after the marketing pitch, this is me, what I do. Usually I'm architect and a data engineer, and I try to help people don't commit mistakes or big mistakes with data. I work in all things regarding search and data processing. That means mostly my day-to-day duties are regarding Solr, Elasticsearch, yeah, all the usual things of a data engineer with databases, etc. I used to be also an open source, and I'm already still an open source contributor in many projects, especially Apache projects, like Nifi. That's an awesome tool to move data. Yeah, and I really encourage you guys to adopt open source. Why? Because it's awesome, and it's a great community usually. Last but not least, I can talk faster than you think. And that's actually true. And I've been accused of that mistake a lot of times. So if I try to speak slowly, if I speak too fast and you don't understand anything, don't hesitate to say, slow down. You know, you start doing like this, and then if I'm not blind by the camera, I'm going to understand that I'm talking too fast. So let's make, no, now. Okay, this is what I was saying. One of the people I work for is Springernature in Berlin. We have an awesome team of engineers building awesome products, high quality. We work for Scala. We do a lot of things with big data, with search, etc. We are very diverse. So we have, I think it's 40% of the engineering force is women, something that I promise I've never saw that in Berlin, never, ever. We have a great manager and all the selling things that I can say. And we're looking for people. So if you are in Berlin or want to move to Berlin, talk to me. What do I want to talk today? Basically, what I want to say, I'll do a very quick review of what data engineering actually is. There is a lot of misconceptions around the topic. I see many organizations who confuse what a data engineer is and a data science. And when you confuse that things, usually pain comes because you actually deploy Python scripts in production. We're going to see the evolution in history from the data-centric organizations. So what people was doing in the past with the data, what people is doing these days. We're also going to review a little bit of facts and skills for data engineers. If you want to get great people, these are tips that work, has been working for me, and I hope they continue working because they attract the talent that want to work on that thing. And also a few tips how to actually develop this talent in-house, because it's actually way better to get people in-house moving and not hiring everyone from outside if it's not necessary. So what is data engineering? Data engineering is nothing new under the sun. We have been doing data stuff since the early days with databases, SQL, etc. But nowadays, the roles has kind of extended. We have data engineers, data scientists, business intelligence, data analysts. So really understanding who does what and when, it just starts to be a little bit like a mess. Especially because after the advent of big data, more or less, the industry become very specialized. We got Hadoop, we got distributed systems, we got databases that are really hell to manage. Elasticsearch breaks, and you have to recover it, and you have to understand why the thing is both broken. Yeah, so you really need a specific people who works on this data infrastructure, in these data problems. As I said, one of the things that data engineers usually work on is with all kinds of technologies. SQL, NoSQL, things like Hadoop, Spark, Flink, Elasticsearch, Redis, Kafka, Java and Scala, etc. So as you already seen, a data engineer is basically the human in your organization that is going to work on the data problems. It's going to be developing the tools, the infrastructure, the procedures, and the methods to make what a data scientist just imagined and came up to production. Usually, it's dealing with the stuff like that it's never thought about it, because when you prepare your data set, it's always awesome. But with data cleansing, conversions, data application, this is very important problems that when you develop and try to your models at the beginning, you never, you don't really find out. A data scientist, on the other side, requires a very big mathematical education. I mean, even if I love mathematics and I grow up in the university doing a lot of mathematics, maybe I can talk with a mathematician, but not really understand what they are doing, if I have to change stuff. This is a quote from Michael Hausenblas. I think he's very well known in Germany as a speaker and consultant. Yeah, I like to extend it also, but it's not quite. I don't think it's very well reading. But what it says at the end is, while data engineering needs a solid understanding of several topics, your data engineers need to understand about distributed systems. As I said before, you get an Elasticsearch instance, and it's going to be a distributed stuff that's going to break. And when it breaks, it's going to be fun. Or when you execute a query, and the ranking suddenly changes. Now I don't get the same query response every time. So you have to understand the complexities of a distributed system. Have to understand databases. Have to understand operating systems and software engineering. But most important, have not to forget that data engineers have to have the human interactions in mind. Because, as the colleagues from Sing already said, and a strong collaboration with data scientists is going to happen, and it's better to happen. If these two teams don't work together, then it's a recipe for chaos. This is a small kind of recap of skills, and for ones and for the other ones. As you can see, basically the skills of a data scientist are basically mathematical ones. You get mathematics, statistics, models, machine learning, prediction, and inferences, for example. I can do machine learning, too. I'm a data engineer by education and trade. However, if I have to adapt the model to be better, or I have to tweak or develop a new model to do machine learning, I have my limitations. So for that sense, having in your organizations people specialized on this mathematical side is very, very powerful. And on the other side, we have the guys and girls who bring these ideas into reality. So know about everything necessary, and supposedly like Scala to develop all that things, because everything seems these days bound to Java and Scala. Yeah, so as you can see, the difference is very clear. So before this small introduction to the data engineering world, I want to talk a little bit about the data organization. Because to understand what we are doing right now, we have to understand where we are coming from. Everything started, the usual thing. What we used to do in pen and paper, now we do it in computers. We started by mapping these processes. Accessing this data was unstructured. Accessing this data was under no control. But we had to see the initial models. Have anybody here knows about network databases? No clue? Hierarchical databases? Yeah, so basically, we're basically talking about databases from the 60s, before the relational model There existed some databases, but people realized that accessing this data was a mess. So the Oracle came in. I hope you get the joke. If you don't get the joke, I will explain. This is the Oracle from Matrix. If you are from that generation, that was a very good movie to see. But why I say that the Oracle came is basically because Edward Code came to the rescue of the companies, developing a model that let people query this data. The people process this data in a structured way, in a way that they can get benefit out of it. And this really changed the way that people access data, because accessing data was reliable and was repeatable and was, they could get benefit out of. So yes, the Oracle was born. So first, we review the databases, so how people access data, but there is also a side in how the applications were built. At the beginning, or the easiest thing to build an application is to build a monolith. Like we used to build client-server applications, easy to reason with, not so complicated. Everybody can make their mind on it. Now we have the microservices, and everybody's freaking out, trying to come back to the monolith. But life was kind of happy. It was not so complicated. Only a small number of people changed one data set. Everything was under control. However, in the 2000s, everything changed. Everything was in fire. Because there was no SQL and big data. Suddenly, everybody had to scale. Everybody had to build big systems, And we entered this situation, this awesome situation in technology. We got key value stores, document stores, object databases, graphs databases, big data search, data mining, and and this is even a small chart, so you can actually read something, hopefully. As you can already see, this is a mess. And this is a mess to manage because you need specific skills to deal with that stuff. You cannot expect what many people is saying these days and all the life that, you can have a full stack developer. Yeah, sure. No. It doesn't exist. If we pretend to know everything, especially in this huge ecosystem of thousands of different tools, it's simply complicated. So that's why the role of data engineer came to life. The role of the data humans in your organization came here to help you. But this is not just bad. This is not only bad. This is very powerful. Because with this, we arrive to what I love to say as the rise of the data democracy. This made data accessible. Since the last years, we have more open data than ever. We can process data at the best speeds. We can process data better. We can deal with everything a lot better than what it was before. So this is very powerful. However, every power comes with a price or with a huge responsibility. We have not to forget the human side of this responsibility. Right? As we said before, one side is the technology of the problem, but a very important side is the human side. So we said that we democratize the data, everybody can access the data, we can process more and more data. However, this leads to a typical data anarchism. So I see organizations in my life as a freelancer and as an employee that are really a chaotic thing. You develop a system with an Elasticsearch, a Mongo, a Redis, an Oracle, because you never forget to put your big Oracle in any kind of project. You maybe have another relational database down there. So that's a mess. And that's a problem, because if you are in a big organization or even in a middle-sized organization, many people is changing your data. How do you move, or you are making sure that your concepts and your entities are representing what you want? And actually not just what you want, what is beneficial for your users and for your business analytic people, for example. Yeah. So I always say that from data anarchism, democracy should be governed somehow, So that should be, not everything is freedom in this life. I love to be in freedom, but some government is necessary to make us humans follow rules and make things easier for other people to deal with. So yes, anybody of you knows about data governance? Nope, no idea? So it's an ISO that I'm going to present later on, but it provides a big idea or initial idea how to deal with these data manipulation problems. But before that, we're going to introduce a little bit the flow that usually happens. Usually, we start, as I said before, a single application. Everything is happy. Everybody's happy. You know, your organization is extremely powerful and want to conquer the world. So you finish your MVP, basically. But suddenly, your manager comes to your place and says, now we have to build a business and intelligence team. Or even worse, can come to your boss, to your office, and say, now we have to build a data lake. So even more people is going to touch your data. So you enter having multiple applications, multiple services. You start by having to coordinate who changes the data left and right. But also, more important thing, we are getting data from other services all day. We are getting, I don't know, API. We are consuming APIs. We are consuming other systems. We are integrating a lot of data. So everything needs to have some kind of governance. We have also something that can happen. Your company just bought another one. Different data schemas, different models, different everything. So all of this is what is usually a system integration problem. And it's part of this governance problem too. So as I said, the data governance framework is the ISO 8150. Please don't take it as a rule. Don't take it as a law, but take it as a guidance, as something that really tells you that in your organization, if you want to deal with data, you have to get people who is in operations, people who is in quality. You have to get people who is managing the data. I mean, and I work for a huge organization as Springer, for example, and we get data and metadata people that are responsible for ensuring that everything is in good shape. Everything is how we want it to be. Data administrators and technicians. So we, as engineers, we are in that side here, responsible of processing, responsible of quality measurement or fixing errors, but there is a huge amount of different roles that can happen in an organization in order to have good quality of the data. So if you don't know before, I really recommend to get a quick check on the ISO. Is very insightful. So we reviewed how the organization was working. We reviewed the history a little bit. We reviewed some of the things about anarchism, governance. But how do I make this governance to happen somehow in an agile organization? So here are a few ideas of how to organize your roles in a data world. Usually have infrastructure specialist. You get your teams who sets for you databases, who sets for you your Kafka cluster, etc., etc. They are there to help and to actually provide your development teams with less effort having to manage everything. One of the usual mistakes in data-centric applications or data-centric infrastructures is when teams have to deal with everything from the front end till the infrastructure. You know, it's usually a problem because you cannot deal with everything. And when it's an outage, what are you doing? You're developing features, you're fixing the outage. You know, it's messy and usually lack of this expertise, low-level expertise to understand that thing. Then you get the data technicians. You get people who is responsible of processing. You get people who is responsible of modeling and administration, discovery. Lots of huge organizations and small organizations have the search engineers, people who is only responsible of making data accessible to others to be found. Data architecture. Even more and more these days, there is the role of a data architect. So the guy or girl who have the view of how all the data is moving in the organization. yeah, how do you organize these specialities? Because, everyone have to have an organization. So that's my take. It doesn't mean that this is the only truth, but it's what I've seen in my previous life and my career life. So yeah, usually you organize the infrastructure specialists as a specific team. So these are service teams that maybe embedded or not embedded, but usually live alone and are specialists on that area. You have processing power, the guys and girls who are specifically dealing with making this data accessible to others. You have the discovery, that's another specific team. Or you have the quality control, that's one of the examples, like together with the global architecture team as the main experts that are embedded somehow into the different projects. So here's a question. Have all responsibilities really been extended? Are we doing something extremely different to what we have been doing before? Relational databases are strong. So we do relational databases like before. They are staying here. If you check, I think that's the other index. Well, there is one index that I always forget the name that says the popularity of all the data systems. And there is always like Oracle, Postgres, MySQL, and they stay there. But there is also mass adoption of NoSQL. With the mass adoption of NoSQL, there is questions that arrive to our thing. So do we do schema on write or do we do a schema on read? Does anybody know the difference between a schema on write and a schema on read? Nope. So when we did it back in the days with relational databases, we created a data warehouse, the place where we put all our data for our analytics people. We did a schema on write, because we write, sorry, schema on read. No, forget the other way around. I need my coffee. Everything was predefined and we write the data directly. What we do it right now with things like Elasticsearch, we get the schema out of when we read things, because there is no predefined schema usually. We get things like atomicity and the acid properties. We get cap theorem. But with the ever-increasing need of data, we have batch processing, stream processing. We get SOAP. There is some people working with SOAP. REST, JSON, XML, machine learning. Now we are doing the data lake. More even questions about if you write the schema beforehand or after, or I get the schema after I read it. Relational and bare metal, NoSQL, cloud. So have all responsibilities really been extended? Nah, yeah. And it doesn't work. Ah, yeah, it works. Awesome. Yes and no. We have been doing similar things. What we call now data lake is what we used to call the data warehouse. What we call now a schema on read is what we used to call a schema on write. Everything we are just doing the same thing, but changing some concepts around. Yep. Architectural patterns. More stuff to digest today. So we spoke about data organization. We spoke about mechanism and human interaction of how to govern this data. And now a little bit about architecture. That's really the end-to-end thing in here. Does anybody knows this building? There's no one from Berlin? Amazing. I'm in a talk with no one from Berlin. This is what in Berlin is called architecture. There's a building in Steglitz. It's a tower that's staying here from, I don't know, someone smoked some marijuana when he designed it. But it's a very famous building in Steglitz. So some patterns and tips for architecture layer here. This is a general pattern, a general recommendation or idea on how to build your data analytics layer, your accessing to data layer. So basically we got the data ingestion part, getting sources into something, basic thing. We all do that thing. We integrate different sources, APIs, etc., etc. Most important, one important bit in here is the schema registry. The split bit that you might not see here down there. The schema register is a very important thing because it lets us validate that the data that we are ingesting is actually in the right format. There is a very popular project these days from Kafka who implement this pattern that when you put an event in Kafka, it tells you, yeah, it matches. Yeah, it doesn't match. And it lets you tell if it's backward or forward compatible. So yeah, it's very powerful because it lets our data ingestion part be secure somehow. But it also lets this data publisher component. One thing that happens in organizations is that my schema is going to change. My schema, how I organize an entity, is going to have different versions. Like 1, the 2, the 5, and it's going to have one more field, one less field. And this is always a mess. What do? I just add another field in a table. I remove something. I have always to think how I keep my entities backwards and forward compatible. So the schema registry will help because it's in here. I can ask, please give me the schema for version 1. It will tell me these are the entities. Is this backwards or forwards compatible with the previous version? The data publisher is the component that let abstract all data consumers from versions, changes, scalability, and also responsibility. Because we don't have to forget that when we are in an organization, we can scale our architecture, but it's also important to scale our humans. So like this, we can have a team that's responsible of making data accessible to the other ones, just only responsible of this stuff. Consumers can live their own way in different teams, same way as the analytics. But data engineers can live in here, completely separated and scalable for the rest of the architecture. This is what I was saying, dedicated data ingestion platform, have common formats, please, and please. Don't do like many organizations I see that they have things in XML, things in JSON, things in Abro. Use one. It's not too hard. If you pick Abro, it's very powerful. It's human readable. It's like JSON. It gets backwards and forwards compatible information. It's very easy. But do this thing, please. Don't remove don't have many schemas. And let the schema information be propagated. Because like this, when I do changes, they are still accessible for our data analyst people. Apply data governance. It helps a lot, especially to reduce and to know when something happened. There is one thing that's called data provenance, or how to make sure who changed what and when. That it's very valuable. It's not valuable when everything works smooth and no problem, but when something has happened in this flow of changing our entities, is extremely powerful. And model your flow of orchestration explicitly. There is a word that's sometimes misunderstood and sometimes not used. One of the people I'm working for is a big retailer in Barcelona who doesn't know when a purchase is gone and why. That's because their data is not immutable. They are not working with events. They are not knowing when everything changes. So there is this very famous article from a Microsoft guy who says that accountants don't use erasers. We are working in the analytics team, so we are kind of the accountants of the data that goes past and works. Okay. So more things. Let me grab a bit of water. So we talk about the profession. Now we're going to talk about the skills. And some skills and facts. This is not data for me. This is data from a report made by Ditch that I think everybody should know. But if not, it is a public company that's recently going public in the US that's actually doing fashion things and selling clothing. So yeah, it's very keen on the data analysis part. So they say that data engineers are growing over time. So data scientist is a cool profession to be, but data engineers are skyrocketing. What's the prior role of data engineers? Basically, software. People in data engineering is coming out of software. It's coming out of analysts, consultants, business intelligence. But they're usually not so many changing from data science to data engineer. Where are they coming from? Surprise, surprise, everything is from the US. But you know, it's highly in UK and very heavy on Europe. What's the distribution by industry? Obviously, a lot of the people who says that they are data engineers, they came from information technology services, they came out of the internet, computer software industry. But what is very interesting here? People who do computer games companies, they don't label themselves as data engineers in LinkedIn, because this is data from LinkedIn, by the way. Or in consumer electronics. But yeah, it seems that we are living on this world, and these guys down here are still catching up. What's the distribution per companies? You probably cannot see the names, but it's very interesting that here we have two big names. We have Amazon and Facebook. But the first one is Hewlett-Packard. This was very, very interesting, that most of the data engineers in LinkedIn, they work for this company, for Hewlett-Packard. So going into the skills side, as you can actually imagine, the skill side of data engineers are basically SQL, Java, Python, Hadoop, Linux, and so forth. This one is a very good one. So skills based on company size. Here we get the big ones in orange and the smaller ones in black. We get like the smaller ones are very powerful. Sorry, the big ones are very powerful in Python. Sorry, the smaller ones are very powerful in Python, Java, JavaScript, MySQL. But the big ones are actually very powerful in Oracle, business intelligence, data warehousing. This actually match my experience. When I go to a company, let's say over 1,000 employees, they all have their data warehouse and their big Oracle they're trying to break and have in something else, more scalable. But in smaller companies, they all work with, let's say, more up-to-date technologies. Skills between data engineers and scientists. Data warehousing, Java, Oracle, so forth, very popular among engineers. Less popular among engineers, data analysis, statistics, machine learning, data mining, MATLAB, Python. What we said before, data scientist is the mathematical human in your organization, while the data engineer is the guy or girl who bring things to production. And last 5 minutes, so this hopefully is going to take 5 minutes. Hiring an in-house talent. Because we want to build a very cool organization for people. We want to build the place and keep our talent for us and not for the company together, close by ourselves. We want to hire. Some factors that helps hiring. Remove the walls. Actually, people in data engineering and data science want to work together. The same way as Xing was saying before, that they work in the same team. And they work in a close collaboration. Build an enviable team. Smart engineers want to work with people they can learn from. Get people that's able to teach, get people that's able to share, get people that goes to conferences, get people that's able to mentor your colleagues. And last but not least, one very important one, have an environment where creativity is free. So one thing that not so many companies are doing, and that is very powerful, for example, for Springernature, we have a 1 day every 2 weeks that's hack day. Basically, it's do whatever you want, investigate, learn, create new things, and a lot of awesome features have grown up from that hack day time. That's an environment that led you grow up and investigate and create new things. If you give them freedom, they're going to create and investigate stuff. Hiring. Focus on the right kind of people. If you are in the BI, warehouse, data lake, ingestion, strong focus on data engineering. This is one kind of data engineer. If you actually deploy a huge Spark thing, or you are, part of a service team who is helping other people understand Spark, get people who understand this tooling. That's another kind. Architecture. Usually the end-to-end thinker, going from data processing to how the team's using it. Another kind of data architect, data engineer, the guys and girls who have the whole picture. And last but not least, the infrastructure. These are very important roles. You have to think in that 1, 2, 3, 4 points. And then you will really have someone. So for example, if you want to build your BI warehouse and you get an infrastructure specialist, you're probably not going to like it a lot. And same way for tooling or architecture. Happened, for example, in one of my clients these days that there is a lack of tooling. So the knowledge on the tooling is missing. Yep. And last but not least, few references. The study I was saying, I really encourage, if you are curious, to check a couple of articles from Gartner. I know everybody don't like Gartner, but they provide an awesome set of information for how the technology is going. And last, a very interesting blog post from Jai Krebs, that's one of the creators of Kafka, explaining how these architectures can be built. And will work. That's all, folks. Thank you. If you have questions, you will get a nature thingy. If not, you will get it anyways. I don't want them to go back home. So, do you have questions? Even with a bribe of a Nature magazine, you don't have any questions? He wants the magazine.
I work for a smaller company, and I think this is something we haven't done really any work on. Data analysis. I think we have interesting data for our customers, but we don't really use it. So my question would be, how would you start if you really have nothing done with it at all? So how do you start with data analysis?
So the question was how to start with data analysis. So my recommendation for this is, if you want to start, you need to hire data analyst people, because this will let you get the insights from the data. When you want to bring this to production and to real life, you have to think about getting someone, a specialist on the data engineering side. Both together will do an awesome job. One without the other, probably is going to do a mess up. But that's what I was saying. First, start hiring a data scientist and a specialist on getting meaning out of your data. And when you have your meaning, hire or have your knowledge in how to bring these things to production. You're welcome. So, you want a magazine? The other one. This is the good one. So he was the smarty pants who asked the first question. So more questions? Nope. Yep. Another who wants a magazine. I'm just kidding, by the way. Yeah.
Do you have some advice on what the fraction of data scientists would be to a data engineer?
So the question was if I have some advice on the what's the fraction of data scientists versus data engineers. I will explain a story. I'm working for an organization that have 25 data scientists, 2 data engineers. This doesn't work. So you at least need a good ratio that lets you bring your stuff to production. And both jobs are equally hard. If you don't think, you overstuff one and understuff the other one, you're gonna have trouble. What's a good ratio? It depends. But don't do what this organization is doing. Don't have a 25 versus 2. You know what I mean, right? You get the magazine. Come back after. If you wanna, you also can have a sticker. It's awesome. More questions? Nope, everybody's sleeping. Well, if there is no more questions, thank you very much.